In this video, I'm going to discuss energy and chemical reactions. I'm going to discuss the two cases, and then we're going to come back and work a quantitative problem relating the amount of heat to the amount of material being reacted. So first case we're going to discuss is this one here, where the enthalpy, H, is a measure of the amount of energy in the system, both within the chemical bond, stored energy, and as kinetic energy. So if we take H2 and Cl2, we need to break the hydrogen-hydrogen bond and the chlorine-chlorine bond, but we make two new bonds between hydrogen atom and chlorine atom. There's going to be a difference in energy between these bonds. Well, this graph says that the energy of the bonds is actually lower for the products than for the reactants. And so the energy change is going to be negative for this particular chemical reaction. And so if delta H, the change in the enthalpy, is negative, this is the case you get. This is minus 185. This is called an exothermic reaction. This is the most common type of reactions. And exothermic reactions give off heat. And the reason they give off heat is because the energy has to be conserved. It doesn't just disappear. So if it has lower energy after the reaction than before, that difference in energy has to be manifested some way, and that is heat. Now, this is the less common example, is an endothermic reaction where the product's energy content is actually higher than the reactants. So this would be a good way to store energy in such a thing as fuel. Here the enthalpy change is positive. And this is a reaction that if you were to actually feel it, it would take heat from your hand to help run the reaction. The quantitative problem that we're going to solve for this particular section is how much heat's released when we make 50 grams of ammonia from the elements according to this chemical reaction, which is exothermic. And so the equation would be 3 hydrogens plus 1 nitrogen gives 2 ammonias. And for the reaction in molar quantities, the enthalpy is minus 92.2 kilojoules change. Let's say it's exothermic. So first thing we have to do is convert grams of ammonia to moles of ammonia. For which you need the molar mass, 17.0. Okay, so first step done. Now we need to relate the amount of ammonia in moles to the heat given off. And so that's going to be, from this reaction, 2 moles of ammonia is equivalent to minus 92.2 kilojoules of enthalpy change, or heat given off. So moles of ammonia cancel, and we're left with kilojoules. So all that's left is to calculate this number. Kilojoules.